Imagine a shortcut through the universe that could transport you to another point in space or even time. What would happen if such a wormhole opened up on Earth? Let's take a moment to explore this enigma, the concept of wormholes. Wormholes are purely theoretical at this point, but they are a fascinating part of our universe's potential architecture. They have their roots in the complex mathematics of Einstein's theory of general relativity, which describes how massive objects cause a distortion in space-time that we perceive as gravity. Wormholes are essentially tunnels that could theoretically exist within this fabric of space-time, providing shortcuts between two distant points. The idea of wormholes has captivated the human imagination for decades. They've been a staple in science fiction literature and films, serving as gateways to distant galaxies or even different times. The allure of being able to traverse the vast reaches of space or slip through the cracks of time in an instant is undeniably compelling. It's the stuff of dreams and blockbuster movies. However, despite their frequent appearances in pop culture, the actual science behind wormholes is far more complex and less understood. They remain a mystery, a puzzle waiting to be solved by the brightest minds in physics. Currently, they exist only in the realm of theoretical physics, a tantalizing possibility that is yet to be proven or disproven. Furthermore, there's the question of stability. Even if wormholes do exist, many scientists hypothesize that they would be highly unstable, collapsing almost instantly. However, some theories propose the existence of exotic matter with negative energy density, which could potentially stabilize a wormhole. But let's play with the idea for a moment. What if a wormhole could indeed open up here on Earth? What would be the real-world implications of such a cosmological event? Would it be a gateway to the cosmos, a shortcut to another galaxy, or perhaps a portal through time? Or would it spell doom for our planet? But what would be the real consequences if a wormhole were to open up on Earth? Let's dive into the theories. The theoretical impacts of a wormhole opening on Earth are as fascinating as they are terrifying. Visualize a cosmic tunnel, bridging two distant points in the universe, suddenly appearing in your backyard. What might occur? For starters, we could see some serious gravitational disruptions. Gravity, as we know, is the force that keeps us firmly planted on the ground. But a wormhole, being a distortion of the fabric of space-time, could potentially create gravitational anomalies, causing objects to be drawn towards it, or even creating areas of zero gravity. Now, let's throw time dilation into the mix. According to Einstein's theory of relativity, gravity can bend not only space but also time. Theoretically, a wormhole might act as a conduit to not just a different location in the universe, but a different time. Imagine stepping into a wormhole and coming out in the Jurassic era, or the far future. The possibilities are mind-boggling and slightly unnerving. But perhaps the most alarming theory is the potential for cataclysmic destruction. A wormhole could release an unimaginable amount of energy. If a wormhole were to open on Earth, the energy release might be so intense that it could potentially obliterate our planet. But before you start panicking, remember, this is all theoretical. Wormhole theories are not just the product of wild imagination. They are proposed by some of the brightest minds in physics, built on a foundation of complex mathematical models and observations of our universe. But that's not to say they are without controversy. Even among scientists, there is a great deal of uncertainty and disagreement about the nature and effects of wormholes. While these theories are intriguing, it's important to remember that they are just that, theories. Wormholes remain a mystery that science has yet to unravel. Wormholes, if they exist, could have profound implications for our understanding of space and time. Let's delve a little deeper into what this means. Space-time, the very fabric of our universe, is often envisioned as a four-dimensional structure, where the three dimensions of space and the fourth of time are intertwined. This interconnectedness is a fundamental part of Einstein's theory of relativity. Now, imagine a wormhole as a tunnel, a shortcut through this fabric. Instead of taking the long route through space-time, you could just hop into a wormhole and come out the other side, potentially light years away, or even in a different time. Yes, you heard that right. Time travel. The idea of moving backward or forward in time has been a staple of science fiction for decades. Yet with wormholes, it might not be as far-fetched as it sounds. If wormholes do exist, and if they connect not just different places but different times, we could theoretically step into a wormhole in the present and step out in the past or future. But of course, there are caveats. Traveling through a wormhole isn't like taking a stroll in the park. We'd need to deal with extreme gravitational forces, not to mention the fact that the wormhole could collapse at any moment. Plus, there's the question of how we'd even find or create a wormhole in the first place. Despite these challenges, the potential implications of wormholes are too profound to ignore. They could open up new possibilities for interstellar travel, letting us explore distant galaxies that would otherwise remain forever out of reach. They could provide a whole new perspective on the past and future, challenging our perception of time itself. Wormholes could potentially rewrite our understanding of the universe and our place in it. Whether or not they're real, the concept of wormholes invites us to push the boundaries of our understanding and to keep asking questions about the cosmos we inhabit. Despite the exciting possibilities, there's a harsh reality check to consider. As we delve further into the topic, it becomes clear that wormholes are not as simple as they seem. First off, creating a wormhole is no small feat. According to our current understanding of the universe, a tremendous amount of energy would be required, more than what humanity currently possesses. It's like trying to power a city with a single battery. Even if we could harness such energy, directing it to create a wormhole without causing catastrophic effects would be a monumental challenge. Then, we face the issue of stability. In theory, wormholes are incredibly unstable. They open and close in a fraction of a second, faster than the blink of an eye. To keep a wormhole open long enough for anything to pass through, we would need some form of exotic matter. This hypothetical substance has yet to be discovered and would possess negative energy density, a concept that seems to defy the laws of physics as we know them. And let's not forget about the dangers of traversing a wormhole. If we were to send a spacecraft through, the intense gravitational forces could rip it apart. Even if the craft could withstand the journey, the exit could be anywhere in the universe. It could emerge in the heart of a star or in the vacuum of deep space, far from any known civilization. So, while the idea of wormholes is tantalizing, the practicalities are daunting. The science as it stands presents formidable obstacles. We are still grappling with the basic principles and far from creating or controlling these cosmic shortcuts. The reality is, wormholes remain in the realm of theory and speculation, but they continue to captivate our imagination. They represent a frontier of our understanding, a tantalizing mystery at the intersection of physics and philosophy. And who knows, perhaps future advancements will bring us closer to unlocking their secrets. So, what happens if a wormhole opens to the ground? The answer is, we simply don't know. We've spent our time together today delving into the enigma of wormholes, these theoretical tunnels in the fabric of space-time that could potentially link disparate points in our universe. We've explored their theoretical impacts, pondering the effects on Earth if one were to open up right beneath our feet. Yet, despite our best efforts, we found ourselves staring into the abyss of the unknown. Wormholes, as we've discovered, are a product of Einstein's theory of general relativity. They are a concept born from complex mathematical equations and a deep understanding of the universe's fundamental laws. However, despite the mathematical possibilities, we have yet to observe a wormhole in nature. Their existence remains purely theoretical, and even if they do exist, we don't know whether they would be stable enough for anything to traverse through. We've also considered the hypothetical scenario of a wormhole opening to the ground. Would it act like a black hole, swallowing everything in its vicinity, or would it serve as a cosmic portal, transporting matter to another part of the universe? Again, the answer is a resounding, we don't know. The effects of such a phenomenon are difficult to predict, given our limited understanding of wormholes and the laws governing their behavior. It's in this uncertainty, though, that we find the beauty of scientific inquiry. The unknown fuels our curiosity, drives our research, and pushes the boundaries of our knowledge. It's the mystery that keeps us looking up at the stars, wondering what lies beyond our reach. While theoretical physics may often seem abstract and detached from our daily lives, it's important to remember that it's through these grand questions about the universe that we often stumble upon practical applications and technological advancements that transform our world. While we may not have all the answers, one thing is certain: the universe is a place of endless wonder and possibility, and the enigma of wormholes adds to its intrigue.